Hey YouTube, it's Petey Two Finger back with video number 2 of the tube preamp. So we're going to go through some pictures and information. Let's see, PC printer switch box. That's here's what I like to keep my eye peeled when I go to my resale stores, and anytime I see anything that looks like this, if it's cheap, like let's say it's $1.99, I will pick these up because they you never know what you're going to see in the back of them. This particular one that we had today didn't have 5 of these IOs. There was just 3. But this is the chassis for the tube preamp. When I buy these, let's say I pay $2, there's a rotary switch, and then there's all the wire. All the hookup wire, you take your soldering iron, you can quickly unsolder all this. There's a real lot of hookup wire in here. And that's pre-tinned on both sides. If you're careful when you remove it, you can get quite a bit of pre-tinned wire out of the deal, which is handy for use in projects. And then you end up with I've reused the switch one time. I used the switch. But mostly I get these for the chassis. The wire is just kind of an extra bonus. So taking a look at the photographs that I shot today, let's see, what do we got here? Okay, here's the first image, and this you can see I've painted this black. This is the switch box with its lid off, and this one's a little wider. And that's something you're going to need if you're going to rehouse this tube preamp board. Is a little bit wider to fit in a normal switch box. So as you can see, this one has 3 parallel ports in the back. That's what you're going to look for. This is a 10 millimeter hole. This hole is a little smaller. I used my stepped drill bits to enlarge these holes because they wasn't quite a 10 millimeter hole. I can't tell you the diameter of what it was. And this switch is not being very honest because it's off on. It's not on that particular switch. Here is the back of the PCB of the tube preamp. This is the header. I had read someone got a lot of noise when they used this fasteners, screw down fasteners. He said you're better off soldering right to the board, and that's what I usually do to avoid connectors, is just solder onto the board. And that's what I did in this case. Here's the built-in LED. This LED, it's on the other side of the board. There's an LED here. And I wanted to have a panel mount LED. I tried out this 10 millimeter LED out of my collection. I had bought these off of eBay, and they come with a pre-installed voltage current limiting resistor, soldered in there. And I tested with my meter. It was showing 1.5 volts, and it was showing this side being positive and that side being negative. I went ahead and soldered in the positive lead, and then I had my wife plug the board in, plug the power supply in to the board with no tubes installed. The stock LED on the other side lit, and then I took the black lead and I touched it to this point quickly, and it lit up. So I tested a few different LEDs and I made sure it was stable, and that was basically that. Soldering these 2 wires directly onto the LED. So the original LED is running along with the secondary LED. Probably should have removed this LED and just soldered this one in, but sue me. So yeah, plenty of pictures of this connection for the LED. Here's the input power connection. Note this is a plastic jack, and all of the jacks that I used were plastic, so there's no contact with the chassis. The chassis is not grounded. And this is an AC circuit. It is a 12 volt AC tube preamp, not DC. Here's the switch. I ended up running the switch sideways just because it gave me a little bit more room. And you can see I installed these standoffs. That was the first step, was put this stuff in here, put a jack in the back, and see how this board fits in here. When I got it where I liked it, where it's at, I went ahead and marked it with a Sharpie. And I had to use a pencil too because the Sharpie isn't long enough. A lot of times I probably could have grabbed the fine point Sharpie and that would have worked well, but oftentimes I don't want to bother and just grab a pencil. So I made the 4 markings, smacked it with a small block of wood underneath, smacked it with a hammer and a center punch, and I had a small block of wood at an angle, just kind of right where it needed to be. And then I drilled these holes, and then I used a larger bit to remove the flash, which is excess metal sticking up, which is going to make everything sit at an angle and cause you problems. And if you run your finger across it like an idiot, you're going to be bleeding. So I find that just getting a way larger diameter drill bit and slowly running it, just remove that flash. Not necessarily puddle it out and remove a lot of excess metal, but just enough. So here's the first, this is a 3-conductor, it's a shielded 3-wire came out of an old, really old mixing board. And this is the output wire. I also laid this across here, cut this paper and laid it across because I had done some testing, and then later on my solder laid across 2 points and made a large spark. The capacitors in this board will hold electricity that will zap you. I think it's about 30 volts in this board. I'm not sure. The power supply is 12, but it was lighting up, so I went ahead and made this, cut this piece of paper out and used some masking tape just to shield everything as I worked, because I didn't want to short anything out. And after I did all this additional soldering in here, I used a Q-tip with some rubbing alcohol to remove any excess flux in this area, and I insulated it with an additional piece of electrical tape, which is kind of out of character for me. I try to not use electrical tape, but sometimes you can't avoid it. Here you can see the AC input port, and then the deep well. Always need a deep well. Here you can see the, gee, it's awfully hairy, isn't it? This is my handiwork. What a mess, huh? I did use some heat shrink tubing, and then the nut went ahead and scored it, put a hole in it. You can't always get what you want. I suppose I probably could have had these on the inside, and maybe it would have given me some more room. That may have been a misstep on my part, but they can't all be wieners, right? Here you can see the, is it crooked? Probably. And not so hot on using these screw terminals. And gee, that's not soldered there. On the other side it is, trust me. On this side it's pooled up nice. This one, I split this one in half and wrapped each half around this thing here, and that ended up with a much better connection. But yeah, this is the AC coming in. It breaks off one line through here, through the switch, and the other line goes right to the board. Here's the plastic fitting for the LED. Looking good on the front. Got the switch sideways to give me a little more clearance. Here's how I've got this sloppily. Later on, I hacked some of this tape out. But I left the paper on there. There's still just a little bit of tape holding it on there. And you can see the first step was removing the tubes, so I wouldn't damage those in the process of my my apish construction techniques. So here is this is what you're supposed to use. Stick the wires in here and tighten it down. I read on the internet one guy said he used this and it ended up being real noisy. I don't know about that. I find it easier just to tack them on the bottom and solder them. But you just as easily could tin this stuff. And I did run the power connectors in this. These two are for the AC, and I did run those wires in there and tighten it down this way. So used it for the power, but this is the output, out, ground, out, in, ground, in. And nothing is really labeled as far as right or left, so that's up to you to keep track of that. Or if you don't care, have fun. Here I'm getting ready to do the input and the output. I did one of these too short. I cut it like right here. I'm like, it's right there. It's just going to 90 and go right there. And I cut it short. And then when I use my, I have a one-handed clicky-clacky wire stripper, and it completely pulled all of the insulation off. So I had to run shrink boot down on all three of these and then insulate them and then wrap some tin foil around it to create a faux shielding, tape it all off and solder it on there, and then it was too short. So I redid that input, but such is life when you do this work. If you're in a hurry, that's what's going to happen. So here you can see my second pair of inputs. I ran these down and double soldered, meaning that there's a 1/8 inch input and then there's a pair of 1/4 inch inputs. There's only a single output, but to be honest, I like using 1/8 inch cables. I really do. This here, that was just excess cable that I taped, and on the inside to hold this LED in rather than super glue it or hot glue or use the supplied plastic plug, which I forgot. I went ahead and soldered this without installing this plastic plug that holds this piece in. I use a little piece of black rubber dum-dum, it's called Bishop tape, and it's this black sticky putty that works wonders when you forget. So yeah, here's the finished product. The second set of inputs, this wire comes down here and gets soldered underneath. There's clearance here. Once this thing has been built, it's like with that sparking that happened, I'm pretty much not going to be poking around in here. The only thing, maybe these aren't the best connection here, mechanical connection. I think ultimately what would be smarter is to remove these, drill it out for this size diameter, stick this through here, and then form some JB weld putty around the inside and the outside, and just double JB weld them in there. Nice. That would be better than that crappy little aluminum fastener that's going to strip out, because they're both not really that good. Like, I used some Loctite to hold these in, but they're not the best. I went and got washers and put washers on the outside and Loctite to make it better, but they're really low cost connector, and it's so small diameter. That's the one really weak point in this build. So I will eventually correct that. It'll bother me one day, and like you can see here, I had one really good washer and then a crappy one here. And this hole was overboard. This hole is just a little bit too big. I tried my trick to remove the flash and dug more out than I needed. So it's not really that big of a deal to me. I know what it is. I know that that's a weak point. I'll be careful when I plug it in, and eventually when it bothers me enough, I'll just use a needle nose, unscrew this, bore it out, and then stick the thing in, make up a batch of JB weld, and let it sit for the night. And that'll be that. And that's that. So I hope you enjoyed the tube preamp. I have to thank my friend Heavy Metal ATC. Make sure you go to his channel and check his video out, see what he comes up with. You can look on eBay for these. This was an $18 6J1. This one's kind of hard to find. They've got some where the tubes sit upright. They've got some where they come with a plastic case that are a little less money. But and this one is highly reviewed. They had really good reviews for this particular one. So anyway, that's the tube preamp, the one that I slapped together anyway. And I gotta emphasize on that this, it was a 3-hour job. I was working as fast as I can. But when you're fabricating stuff like this and doing, doing it in an apartment, not really in a garage with a drill press or anything, and just kind of doing it wrong with a bunch of crap that I have here, that's about as fast as I can work. All right, you guys, I hope you enjoyed the video. Like and subscribe, and make sure you check out Heavy Metal ATC Clementine's channel. He's the guy who bought me the preamp and gifted it to me, so a huge special thanks to him. And he's going to be coming up with a much better use for his, because I know he bought one for himself. So check his channel out. He's got some amazing videos, and I can't wait to see what he does with his preamp. And I will talk to you guys soon. Hug your pets, and peace.